Hi everyone, thank you for visiting the channel. In this video, I will have 6 trichordian EMT rolling offsets. What is a rolling offset? Well, in electrical conduit bending, a rolling offset is a compound bend that is used when a conduit must clear an obstruction or transition to a new surface that is offset in two planes at once, both vertically rise and horizontally run. Unlike a standard flat offset, which moves a conduit up and down or side to side along a single plane, a rolling offset shifts a conduit diagonally across three-dimensional space. In these 6 trichordian EMT rolling offsets, we are going to transition from the wall to the ceiling. To do that, I will use Pythagorean theorem to find the rise plus run equals true offset. So this distance, true offset, will become our offset rise. And then we will find the degree of bend and the distance between bends for all these 6 trichordian EMT rolling offsets. I'm going to start measuring from the laser to the center of the first conduit, 3/4 from to the center, as I have marked on the wall, and from the vertical to the center of the conduit here, we have 4 inches. So now I'm going to square this rise plus run to get the distance here. Using Pythagorean theorem, I will solve for this first right triangle. So true offset equals rise squared plus run squared. So rise squared plus run squared equals 16.56. But we have to find the square root of this number. So it gives us 4 1/16 of an inch. But I want to keep it as 4. So we have to go through this step for every of these 6 rolling offset conduits. Input in a calculator 0.75 square plus 4 square to get 4. Drop the numbers after the decimal point to get 4. For the second rolling offset, I will take the measurement from the one coming from the top, because remember, 3 of these rolling offsets come from below the soffit and 3 from above the soffit. So now from the center of the conduit here horizontally, I'm gonna measure to the center of this conduit 1.5 inches. And the run we have now 5.5 inches. So we are going to find this distance here. So this is rolling offset number 2. The rise 1.5 inch, the run 5.5 inch. So when we square those two factors, we get this number. But when we find the square root of this, we will end up with approximately 5 3/4 of an inch. Using a calculator, we can square 1.5 plus 5.5 to get around 5.70, which then we can multiply 0.70 times 16 to get around 3/4 of an inch. For the third conduit, from the center of the horizontal pipes, I'm gonna measure 1.5 to the center of this conduit here. And the vertical side, we have 7 inches. For the third conduit, 1.5 inch rise, 7-inch run. When we square those two factors, we will get approximately 7 1/8 of an inch. Square 1.5 plus 7 squared to get 7.15. Then we can multiply 0.15 times 16 to get 1/8. Fourth conduit, 2 3/8 rise and 8.5 run. Fourth conduit, 2 3/8 rise, 8.5 inch run. Squaring those two factors, we will get approximately 8 7/8 of an inch. Square 2.375 plus 8.5 to get 8.82, which we can multiply 0.82 times 16 to get 7/8 of an inch. Fifth conduit, 3 inches to the center of the conduit on the bottom, and the run 10 inches. Fifth conduit, 3 inches rise, 10 inches run. When we square those two factors, we will get 10.44, approximately 10 3/8 of an inch. Square 3 plus 10 to get 10.44. Then we can multiply 0.44 times 16 to get 7/16, but I want to keep it as 3/8 of an inch. Sixth and last conduit, 4.25 offset rise, 11.5 run. The sixth and last rolling offset, 4.25 rise, 11.5 inch run. When we square those two factors, we will get 12.26, which can be written as 12.25. Square 4.25 plus 11.5 to get 12.26, which we can then multiply 0.26 times 16 to get 4/16, which is 1/4 of an inch. Our next step is to find a degree to bend each of these 6 3/4 EMT rolling offsets. As you can see, the true offsets we got going over Pythagorean theorem, now they are acting as the opposite to the angle we are going to bend. The adjacent is a fixed 12 inches. For all 6 rolling offsets, the adjacent will be 12 inches. And I'm going to use tangent, which means opposite over adjacent. This is for the first triangle here, 4 over 12. To find x, I have to shift into inverse function of tangent to get 18.4. So here, for the first rolling offset, the bending degree is 18.4. So I'm going to do the same for second, third, fourth, fifth, and sixth conduit. So after we are done with finding the degree, I will work on the hypotenuse, distance between bends. Using a scientific calculator, shift into inverse function of tangent and divide 4 by 12 to get 18.4. You can drop the numbers after the 0.4. Second rolling offset, opposite, 5 3/4. Adjacent is a fixed number, 12 inches. So when we enter this into the calculator, we will get 25.6 degrees. X equals 25.6 degrees. Shift into inverse function of tangent and divide 5 3/4 by 12 to get 25.6 degrees. Third rolling offset, opposite, 7/1/8 of an inch. When we input this in the calculator, we will get 30.7 degrees. X equals 30.7 degrees. Shift into inverse function of tangent and divide 7/1/8 of an inch by 12 to get 30.7 degrees. Fourth rolling offset, 8/7/8 opposite. When we enter in the calculator, we will get 36.4 degrees. X equals 36.4 degrees. Shift into inverse function of tangent and divide 8/7/8 by 12 to get 36.4 degrees. Fifth rolling offset, 10 3/8 of an inch opposite. Enter in the calculator to get 40.8 degrees. X equals 40.8 degrees. Shift into inverse function of tangent and divide 10 3/8 by 12 to get 40.8 degrees. The sixth rolling offset conduit, opposite 12.25. When we enter in the calculator, we will get 45.6 degrees. X equals 45.6 degrees. Shift into inverse function of tangent and divide 12.25 by 12 to get 45.6 degree of bend. X equals 45.6 degrees. Now we are going to find the missing side, the distance between bends, hypotenuse of this right triangle. I'm going to use the sine of 18.4 degrees, 4 divided by hypotenuse. When we go over this, we will get 12.67, which can be rounded to 12 and 5/8 of an inch. Divide 4 by the sine of 18.4 to get 12.67. Then multiply 0.67 times 16 to get 5/8. Second rolling offset. Offset rise 5 3/4. Degree of bend 25.6. When we enter this in the calculator, we will end up with 13 and 5/16 of an inch. So that's the length of the distance between bends. Divide 5 3/4 by the sine of 25.6 degrees to get 13.30. Then multiply 0.30 by 16 to get 5/16 of an inch. There's the rolling offset. Offset rise 7/1/8 of an inch. Degree of bend 30.7 degrees. When we input this in the calculator, we will end up with 13 and 15/16 of an inch hypotenuse. Divide 7.125 by the sine of 30.7 degrees to get 13.95. Then multiply 0.95 by 16 to get 15/16 of an inch. Fourth rolling offset 8.875, which equals 8.78 rise, 36.4 degree of bend. When we input these numbers in the calculator, we will end up with 14 and 15/16 of an inch hypotenuse. Divide 8.875 by the sine of 36.4 degrees to get 14.95. Then multiply 0.95 times 16 to get 15/16 of an inch. Fifth rolling offset. Offset rise 10 3/8 of an inch. Degree of bend 40.8 degrees. When entering in the calculator, we will get 15.87, which can be rounded to 15/7/8 of an inch hypotenuse. Divide 10 3/8 by the sine of 40.8 degrees to get 15.87. Then you can multiply 0.87 times 16 to get 7/8 of an inch. Sixth rolling offset 12 1/4 offset rise, 45.6 degree of bend. When we enter these numbers in the calculator, we will end up with 17 1/8 of an inch hypotenuse. Divide 12.25 by the sine of 45.6 degrees to get 17.14. Then you can multiply 0.14 times 16 to get 1/8 of an inch. Now that we have all the offset rise, degree of bend, and hypotenuse for all 6 rolling offset conduits, I'm going to start with the number 1, the 4-inch rise, 18.4, 12 and 5/8 hypotenuse. So this conduit is the first at 12 inches. from the edge of the conduit, and from the 12-inch, this will be the hypotenuse, 12 and 5/8 of an inch. So when I bend 18.4 degrees, I should get an offset 4-inch rise. So that's what I'm going to do next. After marking all 6 conduits, this is the 12 inches I left on the at one end of the conduit. This is my first bending mark and the second bending mark. This is the first rolling offset, 12 5/8 of an inch hypotenuse. So we're gonna load in the bender and line up the bending mark with the arrow and bend the 18.4 degrees. Then rotate 180 degrees, push it to the second mark and bend the 18.4 degree. Very simple. For all 6 rolling offsets, the same method. Leave the 12 inches in front of the hook and bend it. First rolling offset, 18.4 degree of bend. Four inches center to center. That's how you have to measure and bend from the center of the conduit here on the bottom to the center of the offset. So this is the first. Second rolling offset, 5 3/4 offset rise, 25.6 degree of bend and 13 5/16 hypotenuse. Remember this 12 inches for all of them, 12 inches from the edge of the conduit, and from here to here I have 13 5/16 of an inch. So I'm going to bend 25.6 degrees and I should get 5 3/4 of an inch offset rise. Second rolling offset, 25.6 degree of bend, 5 3/4 center to center, 5 3/4 offset rise center to center. Third rolling offset, 7 1/8 offset rise, 30.7 degree of bend, 13 15 16 hypotenuse. So from this 12 inches, 13 15 16. So I'm going to bend 30.7 degrees. Third rolling offset, 30.7 degree of bend, 7 1/8 center to center. Fourth rolling offset, 8 7/8 offset rise, 36.4 degree of bend, 14 15 16 of an inch hypotenuse. So from these 12 inches, 14 15 16 of an inch right there. I'm going to bend 36.4 degrees. Fourth rolling offset, 36.4 degree of bend, 8 7/8 center to center offset rise. Fifth rolling offset. 10 3/8 offset rise, 40.8 degree of bend, 15 7/8 hypotenuse. So this mark and 12-inch one to this 15 7/8. 40.8 plus or minus 10 3/8 center to center. Sixth rolling offset. 12 1/4 offset rise, 45.6 degree of bend, 17 1/8 hypotenuse. So from 12, 17 and 1/8 of an inch hypotenuse. Like that. I'm going to bend 45.6 degrees. Sixth rolling offset, 45.6 degrees plus or minus 12 1/4 center to center. So after all bends are done, they look like this. This is the 12-inch from the edge of the conduit. See, all of them are lying here. And this is the other 12-inch of hypotenuse. This is 12 5/8, and this is 13 5/16, and so on. They go increasing. But when we bend, this is how they lie on the floor. You see, here is totally closed, but on this end, you see this spacing. But when we install them, because they are built to be installed something like that, diagonally, not straight. So when we install, we will see that the same space I have here, I will also get here. This is the first conduit installed in place. As you can see, 4 inches from the vertical line to the center of the conduit is right there. And 12 inches, the hypotenuse, is in this point between here and here. 12 inches, but they increase. They go all up to 17 and 1/8. So I'm going to install the other 5. The second conduit installed in place. See the spacing, and from the center of this conduit to the center of the rolling offset, 5.5 inch. And you see this horizontal line start changing. That's because the second conduit came from above the soffit. So the third one gonna go from the bottom of the soffit. And you see this is of conduits here. They are actually at the same level as these ones here. I have them there before just to take the measurements and rise for every conduit. Third rolling offset installed in place from below the soffit, 7 inches center from the vertical line. Fourth rolling offset installed in place, coming from the top, from above the soffit, See, transitioning from wall to ceiling. Fifth rolling offset installed in place. Those are all 6 rolling offset conduits installed in place.